And hello from the campus of Carnegie Mellon University in Pittsburgh, Pennsylvania. We welcome you to Virtual SEI. Our presentation today is how can I enforce the SEI CERT C coding standard using static analysis. My name is Shane McGraw. I'll be your audience moderator for today's presentation, and I'd like to thank you for attending. We want to make today as interactive as possible, so we will address questions throughout the discussion and again at the end of the discussions. And you can submit those questions to our event staff at any time during the presentation by using the Q&A or chat tabs on the page interface. We will also ask a few live polling questions. These will appear as a pop-up on the video console. You actually need to click on the icon in the left-hand side of the video console. That will overtake the video window and you can vote. And we also have a survey that we will offer at the end of the event, and we appreciate your feedback on that. And we will, like I said, we will add that link to the survey in the chat area. And now I'd like to introduce our speakers for today. Mr. David Svoboda is a software security engineer with the CERT division of the SEI. He has co-authored or contributed to 4 books, including the SEI CERT C coding standard and the CERT Oracle Secure Coding Standard for Java. David, welcome.
Thank you, Shane.
Thanks for joining us. Mr. Arthur Hicken has served Parasoft in a technical capacity for over 25 years. He's worked on several projects for the company, including those that address the software development lifecycle, test automation, static analysis research and development, and software security. Arthur, welcome. You're joining us from California, I believe.
Yeah, thanks, Shane. Glad to be here.
You're catching Pittsburgh at the right time of the year here anyway. So.
It's a lot cooler.
Yeah. And now I'm going to turn it over to David. David, all yours.
Thank you, Shane. So today we're going to go over 3 main sections today. We're first of all going to talk about the state of software security, especially in the brand new market of the Internet of Things. We'll go over the CERT C coding standard a little bit, how the rules are made up, and then we'll talk about static analysis and how you can use them to enforce the CERT standard. And Arthur will conclude that with a couple of demos about how Parasoft can help you enforce the CERT C standard.
So I wanted to start with showing you a few things about the Internet of Things. And the interesting part of the Internet of Things is that it's actually quite insecure. If you look at this set of things that we have looped around the screen here, these have all been hacked. We've heard about the GPAC that was quite popular, David, right? Like everybody heard about that. Yes. ATMs are probably a weekly occurrence, various ways to attack ATMs.
All over the world.
A lot of them are running Windows 95, so that's not scary at all.
Or not running Windows 95.
Heart implants, heart monitors, things like that. Pacemakers have been hacked. Printers. Printers are a really interesting thing, like in a secure facility, because people are using printers to exfiltrate data from the systems. The fish tank one I really like, and I put this little fish here jumping because people recently attacked a fish tank thermometer in a casino and leapt from there into the casino's infrastructure and were able to exfiltrate data about the people who their customers, right, the gamblers.
So the fish tank was basically a conduit.
Yeah. And so the thing is that we often think about these little embedded devices and we say, what's the worst that can happen? And the answer is, oh, it's bad.
Yeah, a lot if it's simply a conduit,
so
a channel.
Security can be tricky, right? And we have this picture here, and David and I have seen this picture for, many years at this point.
It was popular, especially among the CERT folks, and for a long time we didn't even know where it came from until about 2 years ago when someone gave us the coordinates. The picture on the right you can see is actually available from Google Street View. It's a hospital in Bielefeld, Germany.
Yeah, and on the left you see we have this security device, this little gate. And this is supposed to block people from coming in, but as you can see from the tire tracks, it's not been very effective.
It's easily circumventable, and you can even argue that the gate is quite effective. It does precisely what it's supposed to do. People did not cross the road going through the gate.
Yes, we've protected the road.
Yes, exactly. It was simply in an environment that was totally unsuitable for.
And what's interesting that we see in the new picture is that there's these little cement pegs along the side of the road. And basically, they have fixed their security problem. So they had a security control, it was not as effective as it should have
It
been.
was easily bypassed, yes.
They bypassed it, and so they put in place a control. And this is a very reactive kind of an approach, but it was effective. Now, to give just to use cars as kind of an analogy for the Internet of Things, we can see that the number of reported incidents of car hacking is going up year on year on year, and that number is not going to go down anytime soon. In fact, I expect it to climb at a steeper rate.
Yes, it looks to be linear, and I thought they were
Yeah,
higher rates.
yeah, I'm expecting to be like super linear very soon.
But then the number of computers in your car is also going up at
And the
yeah,
amount
that's
of
probably a
code.
linear rate.
It's not uncommon for high-end cars to have over 100 million lines of code. So
Yes.
we've moved long past the era when a few developers could sit together, look over the 100 lines of code that were in the emissions system and say, yeah, that's going to do what we want it to do.
Now it's a few hundred or thousand developers.
Yeah, and they're connected to 100 different, ECUs inside of the system, and they're talking, and that's what these icons at the top right are. We've got Bluetooth, we got Wi-Fi, we got cellular, we've got RFID. There's all kinds of ways to reach into the car, and the little car diagram actually shows you some of the distances. And there's some really clever hacks out there, for example, using the tire pressure monitoring system to reach into the car and change things.
Again, you can just be a conduit even if you don't care about monitoring tire pressure.
Yeah, so we took cars that were, 15 years ago had zero cybersecurity incidents to something that is a daily occurrence.
So quickly, just before we move on, we launched our first poll just to give you those results real quick. We have 37% have more than 5 connected devices, another 37% with 4 to 5, and 25% with 2 to 3, and no one at 0 or 1. So people are
Everybody's
just-
got something,
Yes.
and most people have several things.
Yes.
So yeah, a quick list like, do you have an Echo? Those are hackable. Do you have a Google Home? Do you have any form of light bulb? Do you have a thermostat? I was mentioning to Shane, like my goal is that at the end of the hour here, you're completely uncomfortable, right? That you go
Turn off
home.
your light bulb, throw off your thermostat, go back to fireplaces.
Yeah. So and we'll talk a little more about some of these ramifications as we go on.
Okay, so the point we're showing you here is simply that there is the software development lifecycle, and we're focusing in particular on the coding section. People like to think that coders are simply translators. They'll take your software design and faithfully create a program that works on it and is not vulnerable. And unfortunately, the coding phase is where a lot of vulnerabilities actually start. If you move on. In fact, a study showed that 64% of vulnerabilities actually originate during the coding phase. The designer has nothing to do with them. There are design problems too, but we're mainly focused on coding problems. And this is where you get many of your common things like buffer overflows, injection vulnerabilities, cross-site scripting, both web type problems and hardware type problems.
Yeah, and this is a thing that David and I have talked about many times, that you have to recognize that the vast majority of your security bugs are also quality issues, and that the developers are putting them there in the first place. So you really have to get a handle on that.
Well, yeah, the good side to that, of course, is that fixing your quality issues should help fix your security issues.
Yes.
But there are some security issues that people simply haven't really taken notice of, usually because they haven't, no one's tried to hack them, or they haven't thought
Right.
like an attacker.
Right.
So to address this, of course, we built the CERT C secure coding standard. We've also built standards for other languages, but for today we're going to focus on C. The first edition of the CERT C standard was in 2008. We're now on, I guess you might say, the third edition, which is available as a freely downloadable PDF, published in 2016. That is sort of a stable snapshot of the rules, and if you want a more up-to-date version, you want bleeding edge, then you are free to go to our wiki. The website is listed there. You can look at the rules as they currently exist, and you can also submit comments if you, God forbid, find any mistakes or questions.
Or have any great ideas. Right?
Or had great ideas. We're always paying attention to comments that people make. So here's one example of a secure coding rule. This is actually for C++, but the rule format is the same for all of our languages. We start off with a title, and the title each starts with an ID. In this case, it's DCL21-CPP. You can Google that ID and quickly come to our CERT rule for the details. After the title, there's some introductory text which describes exactly what you should be and should not be doing and why the rule exists. And following the text, there is both non-compliant code examples and compliant solutions. The non-compliant code example shows exactly, code that violates this rule and violates no other rule. And that was the hard part. It's really hard to write. It's hard to write secure code. It's almost hard to write code that has exactly one vulnerability and no others.
It's easiest to write lots of vulnerabilities.
And people do that without even knowing it. So we have an example of vulnerable code, and then the compliant solution, strives to achieve the same goal while mitigating the vulnerability. So please take our blue code and use that in your code. Please do not copy and paste our red code. We have to make sure that people don't do that. And then at the bottom, we have a bunch of boilerplate material to showcase other aspects of our CERT rules. First, we have automated detection, and this will simply list all of the software that can detect violations of the rule. In this case, Clang is a compiler that can detect violations if you turn on this warning. There'll be other tools listed here. Parasoft, for instance, detects a lot of violations. We'll also list any real-world vulnerabilities that might have arisen from this rule. We used to collect vulnerabilities for things like integer overflow. We stopped collecting those because there were so many of them.
Yeah, you don't have enough space.
We don't have enough space. It would overflow the wiki. Related guidelines, which is other guidelines in the same language, in this case C++. We would also show guidelines in the CERT C or Java standards, and we would show guidelines for other coding standards such as MISRA. And then we have a bibliography at the bottom. But the most important section that I have not gotten to is the risk assessment. So each rule has a risk assessment that dictates various aspects of the rule. You can use these risk assessments to triage and decide, I'm going to deal with this rule and not deal with that rule later on.
Yeah, and I think this is really cool. We're going to go into depth in this because it's really powerful.
Yes. Having this prioritization of the rules makes for fixing things a lot easier. So the risk assessment consists of 3 metrics we take. The first is the severity, where there's 3 values. If a rule is low severity, that means the worst that you can do with it is cause the program to crash or hang. That could be bad if the program is, say, maintaining a web server or is running your pacemaker. But under most circumstances, I'm guessing that crashing or hanging is not necessarily that bad. You just restart the program. Severity level 2 means the system you can exfiltrate information from the system. Or you can sometimes you can use it to modify the information that's in the system, but you can't necessarily run your own code. Stage 3, the worst severity, is that you can run arbitrary code, whatever you want. You can have the system play the game of life, or you can have it just report all the information that happens. Now, the reason we rank these severities is that if you have medium severity, then you almost always will also have low severity. If I can exfiltrate information from your code, I can almost certainly crash it.
Right.
My mom can usually crash code as well, and she usually has no idea why she did it, just that it worked. And likewise, if you have high severity, if you can run your own code, you can pretty much see any information in there you want to, and you can crash things. So that's why we prioritize the severity in those 3 levels. The next thing will be the probability. How likely is it for a vulnerable code to be exploited? And there we just simply say 3 levels: unlikely, probable, and likely. And the final thing is, how difficult is it to fix the code? That is, can the vulnerability be detected automatically? Can it be fixed automatically by some code rewriting mechanism? And this time, the highest level is actually the easiest and cheapest to fix, all automatic, and the lowest level is the hardest to fix, all manual. And that means, if you move ahead, that the highest numbers are the things that are likely to get to run arbitrary code. They're very likely, and they are very easy to detect and fix. Those are the red things. Those are the highest priorities. And the lowest priorities are the ones that have low severity. You can only use them to crash code, and it's unlikely they'll happen, and they're very difficult to fix. So these three metrics each yield a number between 1 and 3. We multiply those numbers to get a probability, which will be a number between 1 and 27, where 27 is the highest priority, the most critical problems, and 1 is the lowest priority. And therefore, we then partition these priorities into 3 levels, 1, 2, and 3. Again, 1 is the most severe, the most important to fix, and 3, the green, is the least important to fix.
So everybody take a good look at this little chart, because there's going to be a quiz later on.
There will be a quiz. So I bring this up simply as a related material. People often will speak of the CIA triad, that is confidentiality, integrity, and availability. And this maps pretty somewhat closely to our severity metrics. The availability, whether your software is still available, corresponds pretty neatly to our low severity, level 1, where crashing a program or hanging it makes it unavailable, but it doesn't necessarily cost you the other two metrics, the other two aspects, integrity and confidentiality. And those both correspond to a medium severity, where being able to leak sensitive information, costs you your confidentiality, and being able to modify the information costs you your integrity. The CIA doesn't really have something that's analogous to remote code execution, but if you can achieve remote code execution, then you get the ability to crash program, hang a program, or extract sensitive information. So high severity basically costs you all 3: confidentiality, integrity, and availability. So we talked all about CERT rules. They're of course not the only standard out there. A lot of people tend to track on MITRE's CWEs. CWEs took a different approach to CERT rules, because instead of listing a whole bunch of do's and don'ts, they simply partition the set of vulnerabilities into various categories. They'll have a CWE for buffer overflows and one for, say, null pointer dereferences. So we do some mappings between CWEs and CERT rules, and we do support them. What you're seeing here is a set of, the top 10 of the top 25 CWEs that was judged by both MITRE and SANS to be, the most important, the most critical problems to fix. I should add that this top 25 list comes because there really isn't a similar prioritization metric for CWEs.
Right. And the one thing to remember here, when you see that 2011, that really is the latest version, and this doesn't mean that they've been sleeping over there. What it means is that we're still making the same mistakes. So they're still critical to us.
I think the only thing that's changed is that buffer overflows were number 1 around 2005, and now SQL injection is number 1.
Right.
But still, the top 25 is the top 25.
So, did we have any questions coming through?
No questions yet,
Okay.
so we're good.
Cool. So, one thing interesting that we've noticed over the last couple of years is that the rise of embedded systems like IoT has really caused a resurgence in C, and C became last year the fastest growing language, according to TIOBE. And we also see that in some other studies, like IEEE Spectrum shows you like employer demand and job growth and what your chances are, what language you should learn to get a job. And C and C++ are like there again, right? It's no longer just the new hipster languages, but C and C++ will get you a job.
So for a long time, Java was number 1, and Java and C have kind of been doing this do-si-do at the top of the TIOBE index, but now C is pulled ahead.
C is pulled ahead in the growth, right? Like, as we see it growing. And what we're really seeing with C++ is when the devices are bigger and carry more logic, then they're using C++ because it's hard to really model a real-world system in C.
The embedded devices.
Yeah. So the bigger the device is, the more power the device has, the more likely it might have C++.
Right.
So we had another survey, I think, that we were going to trigger up here.
Surveys launched, yes.
Okay, so it'd be great to talk about what are the practices that you're doing. And we've seen here, this is the bar group, and I put 2 years worth in here. So the blue are 2017 reports, so it's really 2016. And the brown are the current ones from the 2018 report. And so we can see how many people are using coding standards, how many people are using peer code review, human code review, right? Like manual code review. how many are using static analysis, and how many are using standards but no static analysis? Do we have results? Or is
Coming in a little bit, so far peer reviews and pen testing are leading the way.
Yeah.
One secure coding standard. So
Yeah.
far.
So it's interesting because we see here, if you look at these little bars on the right, there's a gap between people using coding standards and people running the static analysis tool, especially the 2017. There's a huge gap there. And I always wonder, like, what are you doing? Well, the answer is, it's peer review, right? Like, if you're not doing static analysis to enforce your coding standard, then you're doing it by hand.
Right, and you can, of course, do peer review
Sure.
and detect things by hand. It's a lot of work, especially if you have a single car which has 100 million lines of code. Who's going to sit through peer review 100 million lines of code?
Right, and will you miss things because it's tedious, and how long will it take you, and would you and I come up with exactly the same results? if we
Almost
peer
certainly
reviewed it?
not. It
Right.
depends on the perseverance and the tenacity of the reviewer.
Yeah.
Plus, of course, you have to once you detected that I have a vulnerability, you have to make sure that I actually fixed it and didn't reintroduce it in a later version of the code.
Right. Finding regressions in peer review is difficult.
So yeah, we're actually making a distinction between what's enforceable and what's not here, in that we're simply arbitrarily deciding that static analysis is enforceable because an analysis tool will automatically say, you have a vulnerability here, which is a lot cheaper than having a peer reviewer, look and scan through your code.
And that is a great way to look at it, that static analysis becomes your enforcement tool for your coding standard.
Right. It becomes practical to enforce it, especially for every iteration of your code. The static analysis tool can tell you, hey, good, you fixed your vulnerability here, but you still have one over here.
Yeah. Practical and consistent, which is really important as we start to talk about compliance.
Right. The static analysis tool will also perform the same, whereas Arthur and I might, give you different answers.
Yeah. So it looks like nothing really changed as the
Yeah, peer review is the leader at 57%, and we had 28% at secure coding standards.
So it mirrors closely what we see in terms of the peer review, right, happening.
Okay. So BAR is basically answering these surveys, or the survey results are
Yeah, everybody signed in from BAR Group. So I think we have the next poll, which was around what standards are you using, and there's a whole bunch of them out there, right? Like, and we see here high integrity C++, which is kind of taking off for the new modern versions of C++.
We see here Linux, the Linux kernel.
Yeah, Linux kernel coding standards. We obviously see CERT. The JSF, if you're not aware, that's Joint Strike Fighter, used for the F-35 program. MISRA is primarily used in automotive. That's what it was created for, but I do see it in other safety critical places.
Right, it's become more popular in the general embedded community as well.
Yeah. And there's DISA-STIG for people doing defense industry, and there's a lot of proprietary standards. And that's what's interesting here when we look at this, that there's a whole bunch of these, their primary answer was a proprietary standard. What are we?
So we're at 40% for CERT, 40% for other, and I'd be interested for people to type in the chat what that other may be, and then 20% at none.
Yeah, that would be great to fill in some of those others. You'll notice
Yep.
on my slide, I have a big question mark both by other and proprietary, because I don't know what it is. But as David and I were discussing this, 20 years ago it made sense to sit down and think about your own coding standard. Today, I would start with something. I would grab CERT, I would grab, and then look at my needs and build on top of it. I had other needs, but I certainly wouldn't build, ex nihilo from scratch and create a coding standard.
Yeah, I was thinking about that, and I realized one reason that a lot of these created, first of all, as you said, many of these standards are fairly young, but I'm guessing a lot of in-house proprietary coding standards simply came because of style. People, I might put my braces in a different place than you did. I might indent my code differently. So the standards were necessary to enforce one coding style that everyone could adhere to. So security and safety were kind of less important, and they kind of got glommed onto a pre-existing style.
Yeah, kind of like a Frankenstein.
Standard.
Sure.
Right, and a lot of the standards that you're showing here are safety standards, which are not necessarily security standards.
Right, the ones with the red arrows, those you can be following those, and you're going to have safe software, but you're not necessarily going to have secure software.
Yeah, safe software simply means that the good guys are working with it, and it will not hurt them, but it will not necessarily stand in the face of villains, of attackers who are hell-bent on subverting the code, and that's why you need a security standard in addition to a safety standard.
Right. And that's part of having overall a methodology that is being called secure by design, meaning rather than build the software and then try to test security into it, I'm going to build the software to be secure in the first place. I'm going to think about, hey, I'm collecting data, should I encrypt? And the answer in secure by design is I should always encrypt. That's my default. And the lack of encryption would be the exception.
Right, it should be the exception, and there should be really good reasons if you want to do it. If we go back to the software development lifecycle, the fundamental lesson you learn is that the sooner you fix problems or prevent problems, the cheaper your software development will be, and that's why secure by design is such a good idea. It stops the problems before they even arise. You're basically trying to move everything to the left of the cycle as much as possible.
Yeah, and that price goes way down. I've got a blog that's going to be dropping in a week or so all about that, how the costs go down. It's like 60 times. Right?
Yes.
So it's not insignificant. So and the McGraw quote here, and the important part, it's just plain easier to protect something that's defect free than something riddled with vulnerabilities, right? So having good software and having secure software are really the same problem.
They are really the same problem.
So, no other questions coming in?
We had a question coming in from a Joe asking, why are there different standards for C and C++?
For CERT, there are, of course, different standards. For CBUEs are meant to be language independent. They'll cover all the languages. Well, I could simply say that we were funded to build C first,
Okay.
before we were funded to build C++. But they really are fundamentally different languages, and there are still markets for pure C, and there are markets for C++. So doing C was certainly an important stepping stone to doing C++, but it satisfies a large supply of users. Now, when we built the C++ standard, we did go through the C standard and say, this rule is applicable to C++, this rule is not. This rule will be applicable, but we have to change these things about it. This rule is perfectly good, but we probably want C++ style code examples. So the C++ standard has several rules of its own, and it cites many C rules as equally applicable to the C++ standard.
Yeah, and I think it's nice too, because what happens is that it gives people a very specific standard, so that when you go and look at the advice, you're getting advice for your language, which is really great.
Right, you don't have to just take advice that makes sense for C and apply it to C++, because a lot of advice that makes sense for C does not apply well to C++.
That's right.
They may have different technologies for solving the various problems, or they might have better ways of doing things.
Yeah.
Right.
So the trick is, a lot of people have tried static analysis and they get frustrated. Like, how do I deploy it? What are the problems that I run into? And it's really important that you approach static analysis initially, not just from a tool perspective, but from a policy perspective. You need to think about who's going to run static. Which projects have it? What rules are they going to use? Are we going to use CERT? Are we going to use MISR? Are we going to use, our own homegrown things? And are we going to require them? That's one thing I like about CERT, that having rules and recommendations gives me a way to say, okay, I'm going to require the rules, and the recommendations, I'm going to have a weaker policy around.
We can let people ignore the recommendations if they have a good reason.
Yeah. So, and even with the priority levels that we have, I can actually say, hey, anything that's 12 or above, no way am I shipping that software. But if it's a 1 to 8, I'm okay with it.
So in other words, what you can do is, so my biggest problem with static analysis is that when I run it, I get thousands and thousands of problems.
Yeah.
Who has time to fix them all? And I need to triage. I need to decide I'm going to fix these and I'm going to ignore those. So what we can do is, if you go by CERT rules, then you can simply say, all right, let's take the prioritization, the priority, and say I'm going to fix everything that has priority 12 or above, and everything that's below that I'm going to ignore. And eventually, I might decide, all right, I'm going to move that threshold down to 9, down to 8, eventually when I have, as time and money permits.
As we move toward perfect code, yeah.
Yes.
And in legacy code, I might take a different policy. I've seen some very different approaches. Sometimes people say, well, legacy code, we're going to clean it up. And if you've got the time and money, that's great. Sometimes they say, hey, we only want to touch the pieces of it that have changed. And sometimes they say, hey, we're only touching the line that changed when a bug was reported in the field. And there I might use the priority levels and say something like, well, a 27 in legacy code gets fixed today, because that's the thing that I didn't realize was there. That's my 0 day sitting and waiting for me. So we've got all the mechanisms, but it's that thing you need to think about first. You can't just go run, 100 rules against a million lines of code that are, 5 years old.
It is seriously diving into the deep end.
Yeah. So having an idea first, what you're doing and why and how much that's achievable is really important. I'm not sure, did our poll come in?
So yeah, we will launch another poll asking about static analysis
Yeah,
tools.
cool. So it'd be great to hear a little about the tools that you're using as we talk about this. Training is another key piece that is often missed. We think, and training here, I'm not just saying, hey, here's the tool, here's how to use it. I'm talking about the basics. What is secure code? How do I use secure code? David teaches this all the time. He's got courses going on. I think, aren't you teaching
Courses for both C and Java. I just taught a Java course last month and a C course next month.
Yeah, so it's important that everybody knows how. And the reason I put hacking in here is that a lot of times developers will be resistant. I don't want to go learn something and sit in a room and listen to a bunch of boring guys talk about software security. So instead, I think if you have resistance, teach people to hack. And I know that it's not as good as getting the secure coding basics, but it raises that awareness. Once I realize that my software could be penetrated, hopefully I'm thinking about it, and that'll help me.
My students tend to have an epiphany when they go through this, when they realize that this stuff is real. This is not just old professors waxing on eloquently. This is not just an intellectual exercise. Exploiting a program with a buffer overflow is doable. It's not difficult.
Yeah, it's easy. It's really easy.
It's a little scary how students who find security boring find hacking very fascinating.
Yeah.
We always have to warn people, this does give you great power. Please don't take my hacking abilities, because I don't want to have to explain to the FBI how this is a really smart kid and he could have hacked your systems.
Yeah, and David raised a generation of hackers.
Yeah.
But also it's important to make sure that your team understands how to use and interpret the standards. Again, based on your policy, when are they allowed to suppress? Do they have to leave notes behind? What can they ignore safely? And why they're doing what they're doing.
When we perform code audits, we always give our clients a report of, here's how many level 27 or priority 27 problems you have, here's how many priority 18s, and so on. And several times, if the people do not have training, then they will fix the most egregious problems, but then as they change code, they'll introduce new problems.
Of course.
And that's what the training is supposed to do. It's supposed to stop that. It's supposed to stop it so that when we audit future versions of code, they don't have more problems than when they started.
And so this is one of the key reasons about static analysis, right? When we're doing pen tests, we're trying to stop these things getting into the wild. But when we're doing static analysis, we're trying to slow down the injection of these problems into the system.
While they're still being coded, yes.
Do we have results?
Yeah, so we got 37% Parasoft, 37% other, and 2% or 25% on CPP check.
Okay, so a lot of
They like you.
Yeah.
Okay, so our people came in. That's great. That's good to know. So I wanted to actually show one of the key things again about being successful is making sure that the static analysis runs in the IDE. And I actually have a little demo that we can display, so let me pop over to that. So this is a standard IDE. This is Eclipse. So we have my project on the left. I can select files. And I can run static analysis on whatever arbitrary set of files I want or on the whole project. And what I can do is from the menu, I can pick my various static analysis configurations. I have a bunch of compliance ones. Out of compliance, I have security ones. And of course, I have a CERT one. We do cover every guideline in the CERT C rules.
Wow.
Every single one, and most of the recommendations at this point, and most of the CERT C++ rules. And we're moving toward 100%. It'll be there. So you run it. At the end, you get this little nifty report. It's showing you how many files have I checked, how many violations did I find. And then in the list of violations, you can actually sort it by file name. You can sort it by what type of violation, what severity of violation, what rule did we violate, et cetera. There's a lot of ways to slice and dice it. When you click an individual violation, it does what you expect as a developer. It takes you right to that file name and line number. You hover over it, you can see the violation. If you go to the line, I might have, in that case, 4 violations on one line of code, which is not uncommon.
Unfortunately, it's not.
Yeah, and then as you see, I can right-click the violation, and it takes me right into the docs. So now instead of saying, well, I don't know why that matters, I can look and say, oh, here's the problem, here's the benefit, here's, as you've done, here's the bad code, here's the good code, which tells you how to fix it, and we can lead right back into the CERT website, even from our static analysis tool, from the developer IDE. He doesn't remember that CERT wiki link, right?
No,
but now
he
he can
doesn't
just
have to.
click and go straight in. And then we can even suppress from here, and we can suppress in multiple ways. We can suppress in a data way that stores them in a separate file, and we can suppress right in the code so that it persists, which is really great if you're in an audit environment. Because if you need to prove that, yeah, we found that violation, we looked at it, and we deemed it okay, here I've highlighted, I have a comment in the code. I have a really poor excuse, which says it was a test. Okay, like put a good excuse in there if you're expecting an auditor. But
Yeah, you can explain that to your auditor later on.
yeah, why test was acceptable to you.
Well, that's what an auditor is for, to make sure that the reasons that you deviate from the code are valid. And he can simply say, sorry, I'm failing that one. But if you have a good excuse, he can say,
Yeah.
yes, that's fine. Your code passes.
Exactly. And again, in embedded, I often think now about safety critical. Is it a medical device? Is it a car? Is it an aircraft? Is it a factory control system? Does it matter when it fails, right? Like my Nest fails and it might make me uncomfortable, but that's about it. But
Well,
when
you're in Los Angeles. When does it get too cold in Los Angeles?
it gets too hot, right?
Well,
Like
yeah.
I might cook the cat or the bird or something, right? Like,
Sorry, if my Nest failed in Pittsburgh in January, I'd be quite unhappy.
That's true. And that's the thing about these risk assessments. So there's another poll that we start. Great.
It is up, yep.
So the bane of all these tools is that you get, there's a belief out there that there's a ton of noise from these systems. And I like to use the word noise more than false positive because there's really a lot of reasons around noise, right? And noise can be that the rule itself is just noisy. It's not really a great idea for a coding standard. It can be that the implementation was incorrect.
What you're saying is that the rule itself might generate reports on code that really isn't vulnerable.
Yeah, when you look at the rule definition, it might just not be something that can cleanly be analyzed in a sound way.
Right. There are lots of rules like that.
Yeah. So the rule has an inherent noisiness to it, and then the implementation could be wrong, or it could just be that the path it chose is improbable or impossible, or that the path that it chose through as the checker went through and said, let me see if I can cause a flaw here, that it didn't reach out far enough to catch a framework that was mitigating some other circumstance.
Right. A lot of rules kind of require deep knowledge of the entire program to enforce with no noise.
Right. So
You say false positives. But,
yeah. And false positive is certainly a category of noise, but often I see that people put down like, I don't like this rule, and maybe they shouldn't have turned it on in the first place, or maybe they don't understand it, right?
Yeah, I mean, if they're just learning the tool, they may not have learned that you can turn it on and off each rule.
Yeah, exactly, and I've seen that a lot because some tools out there don't let you turn rules on and off. You have to turn everything on and live with it, and so that does lead to that noise problem. So it's important to understand, do I have the right rules? Do I have the right severity level? Like if I was starting day one, I would take Cert C. I wouldn't turn on the recommendations day one. I would just turn on the rules
And maybe just the top,
and
up
maybe
to
level
priority
one
level.
altogether, right? And see where I'm at. And if there's like 5 violations, I might turn on level 2. If there's 100, maybe I'm going to fix first, right? So it's really about the process that helps you get around this. The truth is that the flow analysis false positive problem, it's real, but it's not nearly as big as you think. More often, the noise...
What is the flow analysis false positive problem?
Well, it's, the flow analysis is making up paths essentially through the code, right?
Trying
It's
to
staring
guess
at the
what
code.
code's doing without actually running it.
Yeah, and trying to guess, and it's making guesses. If I put 7 in here, where will I go from there? And maybe 7 can't go in there, and that's where you end up with a false positive. So it can happen, but it's important to realize that improper configuration, improper training, poor documentation are a much bigger slice of that problem.
Well, definitely, and that's why just the first time you run an analysis tool, there's an awful lot that you just have to learn, and that's why you kind of want a policy around what you're doing with your tool.
Yeah, people should know what.
At least when you
expect.
deploy it for a large number of people, especially if they don't have, if they're not experienced programmers and don't necessarily have secure coding
I have
training.
a simple piece of advice that I give people, which is initially Don't turn on rules that not everyone agrees to. And people say, well, how do I know that? Hey, run it, give the violation to everybody on the team. If somebody's arguing, turn it off for now. I'm not saying that's a good long-term strategy, but in the beginning, find things that are important to you and fix them so you come to believe the tool, trust the tool, get comfortable with the tool, and then start expanding it to where it's more and more rigorous till eventually you're writing bulletproof code.
So it's sort of going into the shallow end of the pool and then working your way towards the deep end.
That's a good idea, and the deep end is what static analysis often feels like.
Oh man, it does.
So we have results, Shane?
Yeah, we got 28% at 0 to 15%, 57% at 16 to 30%, 14% at 31 to 50%, and the rest are at 0. So that was how many false positives
that's
that your tools have.
interesting.
Yes, we actually thought it would be more shaped like a pyramid, with most people predicting over 70%.
We had a small bet, and neither of us won.
Right, we both
I
lost.
was predicting just a straight-on pyramid, like most people at the bottom and fewest people at top, or 0 at the top. And David had a little more faith in people, so that top, he expected like a pyramid, or an hourglass
with like a little bulb at the top.
A little bulb at the top. So what we have is
we have the bulb but no pyramid.
Yeah.
yeah. So it's that's great.
So let me ask you a
Sure.
question in this section. So, like, you're with Parasoft. Have you guys had issues with people thinking of buggy code because of false positives?
Yeah, no, and that is, an issue, especially where if you get like a security team, they choose the rules in an arbitrary academic fashion, not on what's pragmatic, and then just start giving results to people. Then you get this disconnect. I don't know why this matters. I don't know if I care about this. And we call those false positives. And that is the common definition. I didn't like it, so I called it a false positive. Okay. From my perspective as a tool vendor, it's important to understand the difference between a bad configuration, a lack of training, and a rule that's bad, or an implementation that's bad, because then I can do something about it. Right. And if you look at it and you realize, I understand this, I know why someone thinks it's important, it's not important for me, that's okay. But if you look and you say, look, I agree with the rule, I believe it's important, I believe the finding's wrong, you should be complaining to your vendor. Like, they should fix that. Like, people just accept false positives. Like, you should file a PR and get that darn thing fixed.
Right.
So.
Again, because when you're just starting into the pool, you haven't learned enough of the tool to assume that a problem that you encounter is the tool's fault. It's still probably your fault.
Yeah, that's why turning on a small amount lets you be a little more rigorous in inspection, right?
So we had 2 other comments. One from Sachin asking, are you going to show the CERT tool for static analysis? And is that scale? And is that, if we're not going to touch it, I can make a plug that we actually have a webcast on October 17th.
Yeah, we have a webcast
about
we'll discuss go into scale. Today
Okay.
we're going to be showing a Parasoft demo.
Okay.
Yeah.
And then another comment, and this was from earlier, but a good comment from Steve saying, if you get every Nest to simply turn on AC, you could disrupt the electrical grid. That's the real threat of IoT.
I believe that, and in fact, with the Philips light bulb hack, I think it was RSA, but somebody did a study on, because the light bulbs can talk to each other and not just to the hub, they did a study on if you had a city that had a reasonable amount of these bulbs, how long would it take to take over the whole city? It's like 3 days. Right? Like crazy. And the thing about it is, you think, okay, I can turn off every light in the city. No, the Philips light, the old Philips light bulb, make sure your firmware is up to date. It gave you low-level access to the router. So imagine that you had every home router in a city. You're like, what could you do?
Yeah, never mind just a light, just turning off a light.
Forget the light bulbs. That was just an entry point. It was
Try turning off everyone's home internet.
Yeah. So,
Great.
People can struggle being in the dark for a few hours, but can they struggle without the internet for a few hours?
So I promised there'd be a quiz. Here it is, right? We came back to the target, the bullseye, right? This is extremely important to getting that noise down, and that's why I've brought it back at this point. Controlling the configuration, assuming that you've got the right training, but setting up, choosing, am I going to do rules? Am I going to do recommendations? Which severity levels am I going to do? And again, I'd say if you haven't done this yet, the simplest answer is level 1, right? Like, turn on level 1 rules and ignore everything else. And I'm going to show you that in just a minute. But be careful, static analysis is really a process. It's incremental. Start in the shallow end, work your way to the deep end. Don't bite off more than you can chew up front. If you're looking at violations and you say, we're going to fix these someday, then search for them someday. Because someday often doesn't come.
It should happen at some point, but of course, yeah, you have to start off with the top level.
Don't search for things that you don't plan on fixing right now, because it feeds that negative view about false positives and noise.
This is a psychology problem more than a technical problem.
Well, it is.
Yeah. So what we're showing here is simply a whole bunch of projects that code bases that we have audited at CERT, and we have several measures of what we did. Most of the time, we got over 1,000 alerts. You see that in the suspicious category on the right. And we don't have time to go through 1,000 alerts to determine which ones are true and which ones are false. So we just simply picked a handful, a sampling from each different CERT rule, and we marked those as true. And the suspicious ones are things that were not necessarily inspected by a person, but they would violate a rule for which there was at least one true positive. So the main point here again is that there's often too many alerts generated just when you ask for everything. If you ask for everything, you're going to get it, and you probably won't be able to fix everything. So, like Arthur said, search just for the ones that you plan to fix.
Yeah, if you just go and turn on every single CERT guideline that you can, you will drown.
You will drown. So just
just
search for the ones that you can tread.
Right. So I wanted to show what we've done to get around this, and we've chosen to do CERT because it is so amenable to being triaged properly, to being prioritized automatically in a rational way. In addition to having really good rules that are designed to harden your code, not just symptomatic rules. They're really
It was designed for developers, so developers as a training mechanism, so developers could understand them, and the courses were built around the rules.
And that's the great part about the standard. In fact, I have a blog post went live this morning on the blog.parasoft.com about that particular, why we chose CERT. But I wanted to show it to you, so let me pull up the video. And we will show you a sample. So we've taken our reporting system and we've created a whole new dashboard specifically for CERT and security. So all new widgets that are around the CERT item. So we have compliance widgets showing me things about rules, recommendations.
At the upper right.
We have the bullseye, right? I love the bullseye. It's crazy, but I love it. On the left, I can see various levels, just a quick project status, like a traffic light. You can see how many violations I have in level 1, 2, 3. I can see rules by status. Where am I at in my rules? Green is obviously I'm okay. Red is obviously I'm in trouble. How many guidelines are being violated. I can do the same for recommendations as well. So I've separated them here so that I can handle them differently. So it might be that I measure recommendations, but I'm ignoring them in a workflow at the moment. That way I get kind of a baseline. And then it's really cool because all of these widgets, like here I have priority. This is your favorite one, David, right? Like I can just search for 27s, the 18s, the 12s, etc.
And you tend to have very few 27s and 18s and 12s, and it's just the lower ones, the middle ones, which you have a lot.
So the widget takes you right to the top, and each widget can be configured. I can choose only rules, which levels, and the widget live reacts to that filtering. So every widget on here can work that way. I can really get exactly what I want.
And you have that big tree map on your right.
Yeah, and this cool tree map. So again, green is, I don't have any violations. Yellow is I have some level 2s, and red is I'm in trouble, right? So when we click one, it takes us to our violation explorer. So now I see every file that violated that particular standard. I can actually fix them one at a time. I can go right to file name and line number, or I can bulk fix them, right? If I decided this didn't matter or had the same fix, I can click and select them all and maybe assign them all a priority to a person and triage them together. I can set priorities. I can look at the history. When did this occur? What other branches is it in?
So you're tied into version control.
Yeah. And again, we go right into our documentation. As I mentioned, it's the good code, the bad code, and of course always take you back to CERT, right? Because there they've explained exactly why you should do this, why you shouldn't do this. And David and Will and others have put a lot of effort into helping you understand. So the CERT Wiki is really a great place. And then my beloved bullseye, right? Again, if I hover over green, yellow, red, I can see how many violations in each particular area. And it's cool because this one's driven not so much around a developer fixing things, but a compliance workflow that I'm going to file something. So I get my compliance report. I see all my violations that were the worst ones here. And I can just file this off. I can create a PDF and send it to whoever it is, FDA or whoever. But I can also make it fit my policy. It can be just the rules. It can be just level 1. If I am trying to triage here, I could pick things that are only, for example, here, non-compliant. Now I quickly have a much smaller list of findings. So again, any way I want to filter it, we also produce a very handy thing for you, which is a conformance plan, meaning on the left I see the CERT guideline that matters to me, and on the right I see what Parasoft checker did I use to fulfill that guideline. The compliance people always want to know. You can't just say I complied, they want to know how did you do it. So there's a bunch of other widgets as well. There's some great stuff. If you want to play with it, certainly, we're happy to let people play with it and see some really cool, very specific CERT things, all centered around this really core, great work you guys have done with the risk framework, where I can now give me widgets around levels, priorities, severities, categories, and like every way that you guys have to slice the data, I've got it in here, which is really quite cool.
Yes, it's great to see the metrics you have actually being applied and see how many rules are there for say priority 27, how many are there for 18.
Yeah, there's quite a few, right? And you can actually see it from that report and how many you've turned on, and if you've got some rules that aren't firing, you see it, which rules never get violated, which ones always get violated, right? Things like that. Which
it
ones
can also help to
suppress?
measure the effectiveness, which are the important checkers or implementations that you have of the rules.
Yeah.
Which ones are not firing, which ones maybe should be firing more than they are.
Yeah, exactly. And if you've suppressed, you can see all those. So again, it's built around the workflow of a developer and his IDE. It works with CI systems, so whatever build you're doing, automated builds.
But it's also designed to appeal to the auditor who has to monitor all this
Yes.
stuff, who isn't actually fixing things themselves. They just need to reach compliance.
Right. So we have, for example, TÜV certification. So if you're in safety critical, the tool is appropriate for this kind of a use, and then the reports are there, so you don't have to go and gather and create all these different reports. We have them there. You can just file them. So we took our standard functional safety compliance framework, and we said security is kind of, I hate to use the phrase, but it's kind of loosey-goosey, right? Like CERT has these guidelines, but who's enforcing them? And we said, let's assume that people want to enforce them, and let's build a framework that lets you have the flexibility to choose which items you want to do.
We're taking the loosey-goosey out of the security.
Yeah,
That's our goal.
and then we've created a place, again, it's flexible, so you can choose how strict you want to be, but then it enforces that strictness that you wanted with full traceability for auditing. So I'm hoping that we can get ahead of this security problem in this industry. I want more IoT things in my house, right? And they scare me.
I want more secure IoT things in my house.
Yes.
Maybe they can talk to my router, but not the wider internet.
Yeah, exactly.
That's a possibility. But yeah, I would like to trust the IoT things that are in my house.
Yes.
I don't want my microwave to nuke me.
Yes. Do we have some questions?
So we do. We got a question from Chris asking, when can we expect an IDE plugin to support for the embedded tool chain such as IAR and Keel?
So we do work with IAR and I think Keel as well. It depends on what editor they're working in. If people want to throw up your editor, we do support Eclipse and a lot of Eclipse variants. We support Visual Studio. There are ways to use it inside of Emacs, which is probably the most popular embedded IDE, I'd have to say. It's a toss-up between that and VI, but we do have plugins for some of them and plugins coming for more. So.
Okay. And the last one we have in the queue so far is how might a coding standard not be enforced?
How might the
Coding
easiest
should
way
not
for
be
a coding
enforced,
standard
yeah.
to not be enforced is to run your tool, generate a whole bunch of alerts for it, and then just put them in a shelf, put them in the circular file.
Yeah.
Unfortunately, there's a lot of people that will do that because they have been instructed to run static analysis, and that's it. They're not given any instructions what to do with the static analysis tool, and so they do the minimum compliance, which is file in the circular.
That's where they got that policy wrong, right? The policy was a written policy and not an actionable policy. And somewhere in the policy it said you must run static analysis, not you must fix it. You must fix everything that's above priority 12. You're allowed to suppress these others. You must document it. And we do see this. Again, in automotive, in aircraft. And
again, the people who did these rules had the same problem of diving into the deep end. You can't
Yes.
tell people to fix everything that static analysis generates because it will find everything. which is far too much. And they didn't simply say, it would be ideal if they simply said you need to fix the level 1 things. But that would require the politicians to refer specifically to what level 1 is in CERT, which we wouldn't mind. We'd be happy with doing that. But that's
That's why I love the bullseye, right? It's red. Red is
Right.
bad. Fix red.
Right.
Make red go away.
Right.
yes,
Arthur, David, thank you for the great presentation today. We appreciate your time and joining us here today. We had some other questions just about an archive of the recording in the slides. An archive will be available no later than tomorrow morning, either on our virtual SEI page or the SEI YouTube page. Those assets will be available. We'll make a PDF copy of the slides available by tomorrow as well. So again, thank you for your guys' time. Everyone have a great day. Thank you for joining us. Our next webcast, like as I mentioned earlier, will be October 17th, and it'll be Dr. Lori Flynn talking about SCALE, which is the CERT static analysis tool. Have a great day, everyone. Thank you. Great job, guys. Very good. Very good.